Agents can often mess up. They can hallucinate a response in a RAG workflow. They can not be up to date with the version of code that you are using, or they can just plan and do things incorrectly. A common technique to overcome these issues is to use some type of reflection. So what this means is run some sort of evaluation process on the agent response live while it's doing its job. And based on that, if it fails that eval, pass it back to the agent and tell it to correct itself. Or if it succeeds, then you're okay to finish. Today, I'm excited to introduce LangGraph Reflection, an attempt at providing some higher level scaffolding for getting started with that. At its core, it's a pretty simple architecture, to be honest. So there's this core graph. This is the main agent that comes in. And then there's this reflection agent. And so basically what happens is the user input will come in. It will go to the main agent. From there, it will go to this reflection agent. And then this reflection agent will either send it back to the graph or it will go to the end. There are only two assumptions that we make for this pre-built architecture. So one, the main agent should take as input a list of messages. It can take other things, but it should at least take as input a list of messages. And then two, the reflection agent should return a user message if there are any critiques. Otherwise, it shouldn't return any messages. And the reason that this is important is because this conditional edge will look for the presence of a user message when deciding whether to go back to the main agent or to return. To make this more concrete, we added two examples. One is a coding example where it uses a lint checker to check whether the code seems correct that it generated. The other one uses an LLM as a judge to just judge the output. Let's take a closer look at both of these, starting with the LLM as a judge. First, let's take a look at the code. We can see that we install three modules: LangGraph Reflection, which is this higher level architecture, LangChain, which we will use for managing the entry point to LLMs, and then OpenEvals, which is a package we created to do LLM as a judge evaluations. First, we create the main assistant graph. So this is just going to be a really simple single call to an LLM. So we're calling into Claude 3.7 Sonnet, and this agent isn't really an agent. It's just a call to an LLM, but this is just for demo purposes. And it also shows that you can use this architecture not just for super complicated agents, but even for kind of like simple, just single invocations to an LLM. Next, let's take a look at the critique that we do. So here we have this prompt that we're going to ask the LLM as a judge to grade the initial response for. It's going to grade it on accuracy, completeness, clarity, helpfulness, and safety. So this is pretty generic, and if you're applying this to your use case, you'll probably want to customize this prompt and make it a little bit more specific, and that's totally possible. Next, we're going to create this function that does this LLM as a judge bit. So here we can see that we use create LLM as a judge. This is a helper from OpenEvals. We're going to use O3 mini as our judge. And then the feedback key that we're going to want is just pass. We're then going to pass in the outputs as the contents of the last message that we get. Because remember, this is running after the initial agent. So any response from the initial agent will be the last message that we get. And we're not really going to look at the inputs because we're just judging the outputs here. Then based on this, if the result of score is true, so the score is going to be a Boolean. If it's true, that means it's approved by the judge, and we're just going to finish. Otherwise, it's false, and we're going to use the comment field to pass back in feedback. And so score and comment are standard fields that we get back from this LLM as a judge evaluator. We're going to build this graph, and then we're really simple, just going to use create reflection graph, pass in the first graph, pass in the judge graph, get back this app. Awesome. And then we can see here that we have an example query. And so let's see what happened. I'm going to run this graph right here by just running this file. I can see that I get some nice print statements. It'll take a little bit because I asked it for a pretty complex report. I can see that I log something out to the terminal, and then it finishes. So it passed on the first try. Let's take a look at the Langsmith trace to see exactly what's going on under. So here we can see that there was two main subagents here, the graph, which is the first one, and then the reflection agent. So clicking into this, we can see our first call to an LLM here. We have our user input here, and then we get this nice long AI output. Now here, we have another call to an LLM, and this is for judging. And so here we can see our system prompt that we wrote here, and then we can see that we passed in the response from the first graph into here. We can see the output is saying that it should pass, and then there's this reasoning bit as well. And so because the score is true, it's not going any further. Let's take a look at another example, this time with code. So here we're going to install the same packages, but we're also going to install Pyrite, which is a Python linter. We can then see that we have this helper function, analyze with Pyrite. So this will use Pyrite for static type checking and errors. Other than that, it's pretty similar. So we can see that we create a single call to a model. This will be our base agent. And then we create this reflection bit, which will attempt to grade the generated code. So the first thing it does is it actually extracts the generated code from the response. So because the response is just an AI message, we actually need to pluck out the parts that have to do with coding. So we're first going to use an LLM to do that. And so that's what this extraction bit does here. Then, if we did have a call that extracted the Python code, we're going to analyze it with Pyrite. We're going to print stuff out just so we can see what's happening. And then if there's any errors, we're going to pass back in a message to the user. I ran Pyrite and found this with the explanation that we get from the general diagnostics section. We then tell it to try to fix it and try to regenerate the entire code snippet. This is because we're doing extraction on that message in the step before this. So we want it to generate the whole thing. And then we also say that if you're not sure, you can also just ask a question. And this is because sometimes in code, the model might not actually know the most up-to-date syntax. And so rather than trying to generate something incorrect and keep on trying, it should instead try to ask the user for help. Let's try this one out now. Great. So here we can see some initial errors that we get. So one has to do with an import statement. LangChain coma could not be resolved, so I don't actually have this package installed in my environment. Next, I can see that there's some parameter error, no parameter named initial state. I can then see another issue, so cannot access attribute run for class state graph. So there's a few issues here, some of which could probably be fixed by installing the right packages, other of which appear to be a little bit wrong still. Hopefully this helps motivate this general reflection architecture and provides a few examples for how you can use it. I want to call out that it's really important to get a good reflection agent here as well. And that's actually something we'll be working on over the next few weeks, is to provide some off-the-shelf reflection agents for RAG, for code, and for general purpose things. But you should also always know that you can customize this reflection agent to your particular domain and application. You can try out LangGraph Reflection by doing pip install LangGraph Reflection. Thanks for watching.